Hi, welcome back to Spring CS170. I'm just gonna do a couple of quick things to intro for this week. If you look at the student schedule, we're on week 5. So we'll be covering things with algorithms, flowcharts, pseudocode, and have an introduction to JavaScript. So we'll be covering chapters 10 and 17. As you recall, you can see this is all shaded in a different color. So what that means, it's going to be in exam 2. So I know many of you are preparing for exam 1, so that's what you have up here at the top in the white background. Okay. Uh, and yeah, so that's where we're at right now. So I'm going to start stepping through this right now. So I have this, and before we start, just a quick reminder, you'll see these are all of like the different tags and whatnot that are in scope for what we're doing. So do take a look at these things if you don't understand any of these and how they should be used. Make sure you let the TAs know, drop in on the lab hours or whatnot, post to Piazza, something like that. Um, we will be providing like a sheet with these same tags, but I'm also posting this up into my resources, so you can also take it from there. So there'll be a number of places where you can get these tags, right? So my only suggestion, like I've mentioned in the past, is that you have all this, you have the tag, and you have like a meeting here. It would be kind of nice to actually see like an example of it, what it actually would look like if you put something in here and then what it looks like on HTML, which I think you've done some of that, like I asked you to do for extra credit on the table stuff, to play around with that and some of the styling and stuff like that. Um, go ahead and try it out. It's good to have that for reference. Um, I think I've mentioned to you a few times, this is obviously a big portion of the first test. So you can imagine it's going to play out one of two ways. One will show you some HTML and say, what is this going to look like, right, when we render it on the browser? Or number two, we'll show you a browser and say, what was the HTML used to generate this? Okay. So have a think about that and say, okay, if that were given to me, how am I going to address that? Right? And it's certainly easy enough. Like I said, this is a very basic list of what's in scope for you, so it's not that many things. Think about it, try it out on your own. You can use the HTML5 editor that I suggested, where you can put in HTML on the left and you can see the output on the right, and just play around with it. Make sure you understand going both ways. If I show you the browser, what that looks like, what's the HTML for? If I show you the HTML, what's the browser going to look like? Okay, again, we're not going to ask you to identify what is the font, what's the size of the font, or something like that. But you can imagine very easily we'll ask you to put together lists, ordered lists, unordered lists, tables, right? Uh, you know, with multiple columns, merging column on the headers. You remember that, the column span, those type of things. So just a suggestion here. You remember last week we also covered the escape character, so we might have you put together a couple of things where we want you to show these type of things using the escape characters in your browser. So make sure you have some examples of that. Okay. So anyway, enough on that. There will be a sample exam that's posted out there. I think this week probably, a lot of you will go to lab hours or talk to your TAs, office hours, whatever, to cover any of the material for the first exam. Okay? All right, let's get on with it. So this part we're talking about algorithms. When I get back to my page, I'll also put in the resources for this week, but it's basically chapter 10, right? So you'll see that in there. There'll be some questions in there you can look at and stuff like that. Okay, so here, okay, it basically just talks about, from our standpoint, we're talking about programs as implementations of algorithms, okay? I mean, that's the way how I would describe it, right? And I think probably this last line here where it say the words program and algorithm are used interchangeably, okay? Uh, well, but they shouldn't be, right? And like I said, I think the way I would explain it is that algorithm is the idea, just like you look at the recipe book, right? You remember the last week's lecture, we talked about recipes, right? So you have the recipes; those are things that has to be done, and then the actual implementation of it is the program. Okay. So this is an example. You talked about how we converted the binary to decimal or vice versa, right? So it talks about the steps for doing that. So uh, you've already followed this, right? In fact, this is part of what you're going to be doing in the exam, right? So you just think to yourself, what are the steps that you follow to convert the binary to decimal? And for something like this, which is also why I did in my demo the Excel spreadsheet, right? So something like an algorithm for converting binary to decimal, it's fairly straightforward to take those steps and implement them into some sort of computer program or code. Like I said, that's why I was able to implement something like that into the Excel spreadsheet. It's fairly straightforward, right? It's very clear steps, what you do with the input and what your output will be, okay? So yeah, so the reason why I mentioned that, we'll come to something a little bit later in terms of heuristics. So we'll draw a comparison between algorithm and heuristics, okay? And then down here is just some examples of algorithms. Like I mentioned before, you have a recipe. You may have like these directions from IKEA, doing laundry, stuff like that. So here, yeah, just something that's saying, well, maybe it's a bad algorithm or a non-existent algorithm. You end up in little log jams like this, okay? So here we are. This is kind of what I was leading up to, algorithms versus heuristics, okay? I would say, to sum it up very quickly for heuristics, I would just say it's like a rule of thumb, right? Ballpark idea, quick calculation, maybe something you can kind of do in your head or whatever, but it's not quite uh, these discrete steps, uh, taking something in and generating something out, uh, such that you can implement a program for it, okay? So heuristic processes. So, and we'll go into this a little bit when you guys start doing more with programming, the idea of doing debugging, okay? So you're not going to really have like an algorithm that you can implement to do debugging, but there will be heuristic processes that you would follow to help you isolate bugs in the program. Okay, and that leads into some other further discussions about, you know, what what can programs do, what can computers do versus like what let's say people can do. Okay, so algorithms versus heuristic process. Like I said, like the long and short of it, I would just say heuristic process is like a rule of thumb thing, which it would not be really possible for me to just slap together something on an Excel spreadsheet like I did with the algorithms for converting a binary number to a decimal number. Okay, so the example they're talking about here is to find information on a search engine. Okay, so you have a general idea. You say, oh, I want to search for something. You go into your, well, let's say Google. Right? You go into Google, you do some search. Um, you might find it, you might not find it. So it's something that you explain someone else to do it, they're not really clear, distinct steps where you're going to have like this output coming out the other end, right? It's a rule of thumb, right? Okay, so what are we looking at when we talk about algorithms? Well, okay, you have to have some input, right? So uh, going back to the last week when we talked about the fetch um, execute cycle for a computer, um, it's going to act on something. It needs some input to do something, right? So it's got to go and get something from those memory locations, if you remember that. So that's kind of one of the steps for an algorithm, right? So something has to come in. So what's the data that comes in for you to do some action on? Okay, so um, that's first step. Uh, and then obviously you're gonna have to have something that comes out the other end, right? You need some output here. Okay, so this is fairly straightforward. Don't know if you need to say compute batting average, just say algorithm to compute an average, right? That covers everything really. You don't really need to care about a batting average, right? But has some sort of average, right? So you know what you're going to pull in, right? You know what you're going to do once you pull those things in, and then what's your output going to be, right? So this is your output, right? Um, Specify. So that's part of the algorithm. Okay, so first one, you have your input, now you have your output. Okay, so now here's this idea of, I'm not sure if I pronounced this right, definiteness. Okay, uh, so you take very clear steps um, for the steps you're gonna do to process this input and turn it into an output. Um, I'm going to step back to the example we've been talking about with the binary to decimal conversion, right? So you go down each and every single place or every single digit of the binary number. It's either a 0 or a 1, right? And then that that placeholder times whatever like that 2 to the exponent is and add them together, then you have your decimal number, right? It's very clear, distinct. There's no black, it's black and white. There's no shades of gray or whatever in between it. Very, very clear steps to go from your input to your output, right? And just like the last slide we just talked about, computing the average, right? There's no haziness about it, right? It's very clear and definite. Okay, so that's what they kind of mean when they say definiteness. I don't even know if that's a real word, but that's what it means. Okay, definiteness. Okay, so and all this is just saying is that once I program this into the computer, let's say, like it can go and do it. It doesn't need me to nudge it along to give it some guidance, right? So it's not like this whole like feedback thing that comes back and says, oh, hey, you need this more information. I need to do this. I need to do that, or help me along. Give me a hint on how to do this, right? Um, you don't need to do that, right? So the algorithm should be able to stand on its own, okay? Uh, and you can do this without any extra special ingredients or something like that, right? Here's the steps, just go do it, and out comes something, okay? So these are the type of things you need to look at to generate your algorithm, okay? Um, let's see here. So actually I should slide this out. I'm not sure why this slid up there a little bit. So let me slide this back down to here so that these things are in order. Maybe I slipped when I pushed it up here, right? Obviously this should be 1, 2, 3, 4, 5, right? So here's the last one. This is finiteness, right? So this is where the algorithm should stop eventually, okay? Um, so uh, you don't want this thing to go into an infinite loop, right? So, uh, you know, you might have to tweak it so that you make the criteria such that you can finish it, right? Let me give you a simple example. Let me calculate how many to X number of digits for calculating pi, right? Because if you don't do that, then your pi calculation is just going to go on infinitely, right? Um, so you probably want to set something to say, okay, I want to take a calculation for pi out to, I don't know, 6 decimal places, something like that, right? And then boom, it goes to 6 decimal places, and there you go, you stop, right? Um, so that's generally what you're looking for when you say finiteness, okay? So otherwise, you get into what they're saying here in terms of no solution possible or infinite loop, okay? So you want to have some finiteness to this, some clear state. Now it doesn't, like I said, like just I gave with the pi example, it doesn't mean that when you have certain types of things that could theoretically go out for a long period of time, that you can't shape um, the requirements such that it does come to a finite solution. Like I said, with the pi example, I'm just saying compute pi out to 6 decimal places. Okay. Um, let me let me pause here and I'll cut a new video for this one, for the next one, I should say. All right, thanks.